Learning how to factor is extremely important in mathematics. So I'm going to show how to find all the factors of a number and also how to do prime factorization. With using prime factorization, we can learn how to find the least common multiple and the greatest common factor between numbers. Both are useful in finding common denominators. We're finding out if we're trying to factor an expression, how to factor an expression. So these skills, as I said, are very valuable and will be used throughout your mathematical career. So let's look at how do we factor a number, finding all the factors of a number. So let's take the number 12 for instance. The way that I suggest you to find all the factors of 12 is to always write the smaller numbers here at the left in this table, and to write the larger numbers on the right in this table that we will make. So the smaller numbers, by numbers I mean the smaller factors. So factors of 12. Well, I know that 1 times 12 gives me 12, so those are two factors of 12, 1 and 12. And as you can see, the smaller number is on the left, the larger number is on the right. Another factor that goes into 12 is 2. How do I know 2 goes into it? Because 12 is an even number. Any number that ends in a 0, 2, 4, 6, 8 would be an even number. So if it ends in a 0, 2, 4, 6, or 8, it's an even number and will be divisible by 2. So I know 2 goes into 12. 2 goes into 12 6 times. Also, 3 goes into 12. 3 goes into 12 because when you have a number that is divisible by 3, when I add the digits, if the digits add up to a number that divides by 3, I know the number divides by 3. So even though I know 12, 3 goes into 12, I can still use that rule. If I take 12 and add the digits, 1 plus 2, that gives me 3. That's a number divisible by 3, so I know 12 will be divisible by 3. So 3 times 4. Once I wrap around like this and I come to a number, I've found all the factors. Because as I go up this way, I've now found all these factors and I would just repeat. So as soon as the numbers wrap around like this, I know I have found all the factors. Let's look at another number and factor another number. Let's factor the number 24. Now looking at 24, I know it's even. I know 2 will go into it. If I add the 2 and the 4 for 24, 6. I know 3 goes into it. Another thing, if 2 and 3, if a number is divisible by 2 and 3, then the number will also be divisible by 6. So if 2 and 3 go into a number, then we know 6 will go into a number. And by that, it means when I say 2 goes into a number, that means I can divide the number by 2 and it will come up to be an integer. So if 2 and 3 are a factor of a number, 6 will also be a factor. So let's look at the factors of 21, remembering to put the smaller factors to the left and the larger to the right. Maintaining this type of consistency will be extremely helpful later on. So please make sure you always put the smaller numbers on the left and the larger numbers on the right. So 1 times 24 gives me 24. 24 is even, so I just said 2 goes into it. 2 goes into 24 12 times. We know that 3 goes into it because 2 plus 4 is 6, and since 6 is divisible by 3, then this number 24 will be divisible by 3, and of course it is because 3 times 8 gives us 24. 4 is also divisible, and I could tell that because 2 goes into it 2 times 12, and since 12 is divisible by 4, I know 4 will also be a factor. So 4 is a factor, and we know that 4 times 6 gives me 24. 5 doesn't go into this number, but 6 does. So I've wrapped around, and now I know I have all the factors of 24. Let's do another. Let's do 72. So I know 1 and 72 are factors. It's even, so I know 2 goes into it. 2 times 36 will give me 72. 3 goes into it because 7 plus 2 is 9. And since 3 can go into 9, I know 3 goes into 72. Since 2 goes into 72 and it's got an even number for a second factor, I'll know that 4 goes into there. So 4 goes into 72 18 times. 5 doesn't go into 72. 5 goes into numbers that end in 0 and 5. I know 6 goes into this number because 2 and 3 go into that number. So I know 6 is, 72 can be divided by 6, or 6 is a factor of 72. 7 doesn't go into 72. 8. Does 8 go into 72? It sure does. 8 goes into 72 9 times, and I've wrapped around. And I would have known 9 goes into it since 7 plus 2 equals 9, and 9 can be divided into 9. So it's the number that, when you add the digits, is a number that 9 can go into. I know 9 will also be a factor of that number. So those are all the factors of 72. So now let's look at how we do prime factorization. So I could take a number, let's say 15. And we have to remember what our primes are. 1 is not a prime number. Our first prime is 2. After 2, there will be no more even numbers that are prime, since a prime number means that 1 and itself are the only 2 numbers that are factors of that number. So 3 would be a prime number because 3 times 1 are the only factors of 3. 5, 7, 11, 13, 17, 19, and there's an infinite number of prime numbers. So we look for ways to factor a number using its prime. So 15, well, I know 3 times 5 goes into 15, and there are no other 3 is a prime and 5 is a prime. So my terminal ends here, since they're both prime, that is the complete prime factorization of 15. So the prime factorization of 15 is 3 times 5. These are different than saying what are all the factors of 15. If I were looking for all the factors of 15, I'd do all the things when multiplied together give me 15. Well, I know 1 and 15. 3 and 5, no more factors. There are no more factors in these 2 sets of factors. But the prime factorization would just be 3 times 5, breaking up 15 into prime numbers. Let's look at another. Let's look at 18. The prime factorization of 18 I could start with, because I know 2 times 9 gives me 18, but 9 isn't a prime. 3 times 3 gives me 9, but 3 is a prime. So breaking up 18 into its prime factors would be 2 times 3 times 3, and I could write that as 2 times 3 squared. But if you remember to do all the factors of 18, I would say 1 and 18, 2 and 9, 3 and 6, and no other factors go into it. That ends because 4 doesn't go into it, 5 doesn't go into it, and 6 does. I've wrapped around, so those are all the factors of 18. But breaking 18 into its prime factorization, this is how that would look like. It's how we could rewrite 18 numerically, 2 times 3 squared. If I wanted to look at the prime factors of 24, I'd say 2 times 12, 2 times 6, and 2 times 3. So 24 is 2 cubed times 3. And I want you to note, if you do prime factorization, your tree might look a little different. The answer will be the same, but you could have said 24 is 6 times 4, and 6 is 2 times 3, and 4 is 2 times 2. But it still gives me 3 2's being multiplied together, the 2 cubed, and that 3. So no matter how you see to break up your number in primes, when you get to the very end, it will always look the same. And that's prime factorization and factoring a number, getting all the factors of a number.